Okay, we're on the fifth of 5 parts. We're going to decode an encoded message. So now you're given this variable length encoding. In other words, the output of the previous step. We had a message, we had frequencies, and we variably length encoded it. Now we have that encoding, and we want to decode it using based on those same frequencies. And of course, we should get back our decoded message should be the original message. So decode takes an encoded message and those same frequencies. And so what's it going to do? Well, what you do is you start at the root of the tree and you start at the beginning of your encoded message. 0 says go left. Well, we hit a leaf, so that's an A. That means that that's an A. You go back to the top of your tree and continue. 1 says go right. Now we're here. 0 says go left. Now we're here. 1 says go right. Now we're here. That's a leaf, so that's a B. Now we have A, B, and go back to the root again. 0 says go left. That's an A, and so on. So let's see if we see what's going on. First off, we need our tree, which is to make a tree out of those frequencies. Now we have this tree. We don't need the code map. You only need the code map for encoding. For decoding, you need the tree. Okay, and now that's going to be actually the entire tree, and then we'll have our code tree for now be the entire tree, but as we move along we'll kind of move down. So our code tree kind of moves down, and after we get to a leaf we put it back up to the root, to the entire tree. Okay, so now for each digit in the encoded message we need to advance 1 in the code tree. So if the digit is a 0, you want to advance 1 to the left. So our code tree equals, well, code tree of 0 is that label, code tree of 1 is the left child, and code tree of 2 is the right child. So if it's a 0, go to the left child, otherwise it's a 1, go to the right child. Now that you're at the child, you have to check if it's a leaf. If it is, if the len of the code tree is 1, that means that we found a leaf, right? If we're at a leaf, well, that means that the 0th value in the tree is the combined, if you recall, the combined frequency and label. So frequency and label equals that. So like we got to a leaf, and that would be like 13B or 12C. We really don't care about the frequency here, but the label means we just got to another letter. 1, 1, 1, 0, 1, aha, that's a B. So we have to keep track of all of our letters in our decoded results. So our decoded letters is a list, which is initially empty. We just got another decoded letter, that label. And you got to remember to, at this point, reset your code tree back to the top. So the point here is we just got down 101 to that B. Get back to the top so that the next letter in the encoding will start from the root again. And when we're done, you don't want to return a list of the decoded letters. You want to convert that list into a string. And there you have it. And when we run it, it works, first shot. So this function was able to take in a variable length encoding and the frequencies of letters, and it was able to return the original string. So this string is of length 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters. Okay, A, B, C, D, E, F, 6, 1, 2, 3, 4, 5, 6 letters in the alphabet. So fixed length encoding would require how much? It would require, well, 3 bits per character, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 30 bits. Whereas this, 24. So we definitely have some measure of compression going on here. The truer that we are to this actual distribution, the better our compression will be, naturally. And that's it. We have started with a list of frequencies. We were able to, well, we actually started with just figuring out how we're representing a tree and printing it. Then we had a list of frequencies that we're able to convert into a tree like this. Then we had a tree like this that we're able to turn into a code map such as this, mapping individual letters, which are the leaves of the tree, into the variable length code, which is by the edges, the labels on the edges in the tree. Then we're able to use this to encode a message using those frequencies into a variable length encoding. And finally, we're able to run the process in reverse and decode a message that was encoded in that way. And with that, we are done with the basics of Huffman coding.